In the previous video clip, we looked at the anatomy of the heart. Now let's look at the physiology, the function of the heart. The heart is a pump that pumps blood in the body. So from here, we have our superior vena cava that brings or drains blood from the top to the heart. We have the inferior vena cava that drains blood from the bottom to the heart. And we said that the blood they drain is deoxygenated. Doesn't mean that there is no oxygen in it, but it contains little amount of oxygen. Okay, it is deoxygenated. About 75% or 70% of oxygen is in it. So when the blood flows here, when the blood enters here, enters the atrium, simultaneously, blood flows from the lungs through the pulmonary vein, to the heart. The pulmonary veins here, veins are the only veins in the body that carry oxygenated blood. They carry it from the lungs. Remember that the lungs is what give oxygen to the blood. Okay? And the blood has hemoglobin that holds the oxygen. So from the lungs, the blood enters the heart through the pulmonary vein. Okay, so when it enters here and this one comes here, there is what is called atrial kick. Atria, this chamber of the heart, we kick, we contract. With the help of the kick, the blood moves here, moves down forcibly to the ventricle. So the kick helps this valve to open. This valve that we call tricuspid valve will open. The valve is like this. The valve will open. And when the valve opens, the blood enters here. This valve also will open. When it opens, the blood enters here. Okay? So when the blood enters forcefully, the blood will tend to regurgitate, go back again. When blood enters forcefully, the blood will tend to splash back, regurgitate. But this valve that goes like this will not allow it to go back again. The valve that is like this will lock up. The valve will slam shut, and therefore the blood will not regurgitate, move back again. So this blood has no option again than to follow this pathway, to follow this artery. Okay, so this artery that is semilunar, that has a shape like half of the moon, will easily open. Okay, so and the blood will flow like this, move up through the pulmonary artery, and goes to the lungs. Remember that this is the oxygenated. So going to the lungs is to collect what? Oxygen. To get oxygen. After which they will now come back through this. Okay? Through this pulmonary vein. So this pulmonary artery is the only artery that carries deoxygenated blood. Pulmonary artery. It carries deoxygenated blood to the where? To the lungs. Okay, at the same time, this blood that enters here will tend to move like this. So what makes them move in this direction? Because this valve will close. The valve will close. The blood will tend to go back, but this valve will not allow it to go back. So this blood has no option than to flow in this direction. Okay? Then what makes the blood to flow in this direction? Is because of the contraction. This ventricle do what? The ventricle will contract again. When they contract, okay, the blood has no option than to flow like this. So the contraction of this ventricle, okay, we push some blood to regurgitate back, to go back. And when they try to go back, the valve will not allow them, okay? The valve will lock up. And that is when you hear a sound, loop, loop in your heart. If you touch your heart, you hear loop, loop sound, loop, loop sound that you hear in your heart, boom, loop sound. Because of the closing, the slam shutting of the tricuspid valve. When the tricuspid valve slam shut, when they close it forcefully, okay? Now, when this blood goes in this direction and the blood wants to come back again, okay, this valve will not allow it to come back. This valve will slam shut, will close forcefully, okay? The sound of the valve, when you try to close your door, the door makes noise, okay? So the noise, the sound produced by the closing of the semilunar valve is doop, doop sound, doop sound. So in your heart, you hear loop, doop sound, loop, doop, it will pause, loop, doop, it will pause, okay? Okay, so that is it. Now, let's move again. We talk about blood pressure, BP. How do we get the blood pressure? The blood pressure is due to the pressure exerted by this wall. Remember that this wall is a thick wall. Okay? The wall is thicker than every other wall. The ventricular wall is thicker than every other wall because the blood here moves systemically to other parts of the body. It moves a longer distance. The blood that will be here. Okay? So the pressure applied by this wall to the blood, okay? Then the blood will also use the pressure to move out. The pressure is recorded up maybe at the average of 120 millimeter mercury, okay? And that is the contraction. We call it systolic contraction, okay? 120. This 120 can be affected by a lot of factors, by age, by sex, by other pathological issues, okay? Then after the contraction, the heart tends to also relax. After the contraction, it tends to relax by what we call diastole, okay? That will make the pressure here to decrease, okay? So that the volume will increase. When the pressure decreases, the volume will increase so that more blood can come down. And the pressure tends, maybe let me just use 60 millimeter mercury. It differs also depending on a lot of factors involved. We don't want to go there now. Okay, we can talk about cardiac output. Cardiac output simple means the amount of blood that goes out through the left ventricle. The amount of blood that goes out through the left ventricle, the volume of blood that goes out through the left ventricle in a minute, okay, is called cardiac output. Cardiac means heart. Output means going out, okay? Now, cardiac output is gotten using a particular formula, which is heartbeat multiplied by stroke volume. Heartbeat multiplied by stroke volume. So what do we call stroke volume? Stroke volume means the amount of blood that flows out in each beat. Each beat. Beat is contraction and relaxation. It's called beat. When the heart contracts and relaxes, is a beat. So just imagine that in one beat, in one contraction and relaxation, the amount of blood that leaves there is maybe 64 milliliter. 64 milliliter. The amount of blood that leaves there is 64 milliliter in each beat. Okay? Then in 70 beats per minute, if you have 70 beats per minute, what is the amount of blood that will leave here? Remember that one beat makes 64 to leave, 64 milliliter. So this one volume leaving out of the heart due to this one beat, this volume is called stroke volume. Okay? One beat. Volume that goes out is called stroke volume. Okay? Then, in any amount of beats in a minute, let's just imagine that you have 70 beats in a minute. So if I want to know the volume of blood that will go out, it will be 70 multiplied by this one, which is we call cardiac output, which is number of beats, heartbeats, 70 multiplied by this volume, 64. Okay? When you multiply it, whatever it gives you is the cardiac output. Okay? So let me ask you a question. Put it, if you know it, in this comment section. What artery carries deoxygenated blood? Put it in the comment section. What vein carries oxygenated blood? Put it in the comment section. Name the valve that produces loop sound. Put it in the comment section. Name the valve that produces doop sound in the comment section. Okay, if the stroke volume is 70 milliliter, okay, and the heart rate is 72 beats per minute, 72 beats per minute, I want you to calculate what you think will be the cardiac output.